Check. Hello, everyone. Let me wait for one more minute, and then I'll start. Okay, I think I will begin. Hello, everyone. Hope you guys are safe. Thanks for joining this session. I would like to thank Mr. Leo Gertrude for organizing this webinar. Today, I'll be sharing how creative technologies are helping advancement in IoT. I'll be sharing some examples, example projects later on, and I'll show some background about our team setup as well. Before going in, I would like to let you guys know that I'm staying near airbase, so there might be noise when fighter jets are crossing by. So please bear with me. Thanks. All right, let's go in. I would like to introduce myself. I'm Charles Durairaj. A little background about me. I'm a designer turned developer. And I was born in Pudukkottai in India. I got graduated from Karunya University in media field in the year of 2009, and worked in Chennai for about a year, and then moved to Singapore in 2010. Uh, I love game development. So from my bachelor's, I used to develop a lot of games. I always enjoy combining creativity and technology together. And then I also love photography, and I love to travel a lot. And I'm also crazy about home automation. Pretty much my house, like the whole house, is automated because this is one thing which keeps my developer spirit alive still. So that's something about my passion and about my career. I spent the first 5 years of my career in game development. I worked on a lot of MMORPG games, few AAA title games. Um, and one fortunate thing for me was I was able to create games for uh, from kindergarten kids all the way to hardcore gamers. So that is a quite variety of things I learned in game development. I'll be always thankful to. And then I joined Siemens in 2013, and various roles in Siemens. Now I'm heading visualization topics in Siemens IoT Consulting in Singapore. And in order for me to talk about today's topic, I really need to show some success stories. So I brought the story of my team and how we were formed and how we were able to do IoT projects quite efficiently. Our team was formed in 2013. From day one, there was high expectation for us. As you can see, Prime Minister of Singapore, Mr. Lee, our Singapore CEO, Siemens CEO, Global CEO, Joe Kaeser, and a few other ministers of Singapore were also there during our launch. So our role was quite crucial in Siemens when we were formed. We were called Urban Mac then. As the name says, we were focusing on urban infrastructure a lot and industrial applications as well. So our main focus area were mobility, smart infrastructure, that's digital buildings, energy grid, and healthcare, energy, and power industries. These were our focus areas. And in the past couple of years, we have worked on various topics, and we have achieved a lot in these areas. And all these things, what you see here in the screen, are actually the topics. There are various projects underneath these topics. We don't have time for that today, so what I will do is I will show some examples, and some of the places we also innovated a lot of things. So this is one of the list of innovations we did. We are quite first to that. So we did a lot of crazy things. Like one of the thing was like always the traffic management is always controlled by a timer, or like sensors in the roads and stuff. So what we decided to do was like, this is not efficient. So we took CCTV footages, and we took the footages. Based on the footages, we learn how many cars, how many bikes, where are they going, what is the pattern like, what time of the day, what is the weather, and all these things combined. All these things we then tell our traffic management system what are the timing it should do for the red lights and green lights. And this is quite crucial because the more people wait in the road, it affects the GDP of a country as well. So this is in a bigger scale, it makes a lot of sense. So we've looked at from this way. Working on a CCTV camera is not easy. It's not a sophisticated camera. CCTV footages can be in any angle. It's cheap, a lot of things. So we managed to efficiently use the CCTV cameras to do our computer vision algorithms, and this is quite efficient. And again, like creativity, technology, a lot of is involved in this as well. And we also helped our engineers to simulate turbines. For example, engineer to simulate or train another engineer for a turbine. When I mean turbine, it's basically a power plant which generates tons of power. So what the engineers do is they travel to offsite, which is like so far away. Sometimes it's in the middle of the ocean. Like no, they have to travel far away, and then they train the engineers and stuff. This causes a lot of burden for the engineers. So what we did was we cloudified. Now the engineers are actually sitting at the desk and training the engineers offshore. This is also possible right now. Similarly, we did a lot of other equipment anomalies as well. So for example, we predict equipment anomalies without historical data. For example, if for AI to work, you need to train the model, so that with a lot of historical data. So basically, you take 2 years, 3 years of historical data, give it to the model AI, and then it runs and learns from the historical data, and then it will tell that this is what I understood in the patterns, and based on what is happening right now, it might happen in 2 hours, it might happen in 2 weeks, like things like that. It would predict and it would tell. But how would it learn without any prehistorical data, right? That is something which we try to innovate, and then without any prehistorical data, we started actually predicting a lot of anomalies with various techniques. So similarly, I have a few other lists. So the reason why I'm telling this is how we were able to achieve these areas, right? This is quite crucial. And whenever we present our solutions in roadshows or exhibits to all the C-level people, so ministers, mayors, we get a lot of widened eyes, as our approach is very unique, and they always like the way we are doing certain things. And what is the delta we have, other than or other innovation, like we have over other innovation team, is what I wanted to share with you guys. That delta is actually arts and science. So we are innovation team. We have a lot of technology people in our team, but equally we have enough creative people in the team as well. Which means like we have artists. One of the artists also did this art for us, like to represent our team. So I just put it in. On top of it, like we have a lot of innovation consultants. So everyone is trying to learn from the creative side, and then we are trying to learn from the technology side and then business side. So we are equally formulated team with expertise in these areas, and we believe that science grows stronger when there is a lot of creative elements joins. And this is our belief. With that, we found our team this way. We have data scientists, engineering groups, user experience people, artists involved, 2D artists, 3D artists, We have domain know-how experts like mobility experts, like energy experts. We have cybersecurity experts, management consulting, and software developers. And all these people are not. We don't have like hundreds of people. We have our team is very small. We have about 25 people in our team, and with this, the amount of achievements we have done is a lot, and that the only reason for that is that we are equally divided into creative and technology side. But this wasn't easy. We had a lot of frictions at the early stage, but glad that we had a head who understands the importance of it and gave us time to settle the dust and align ourselves. And now that we went through that hardship of understanding each other um, from various aspects, now we are able to provide a lot of information to the team, and then we are as a team together growing stronger. So with that, I would like to jump to project side. I will share three projects here. One thing I wanted to highlight is that there is a lot of confidential elements in these projects. I'm unable to go deeper. I wish and I would love to, but I won't be able to. So, but what I did was I gathered enough information for you guys to see the possibilities and potential of what you guys can do with creative technologies. And that is the most important thing I want to leave in this webinar. So let's jump into the first project, feeding fish. You might ask, isn't that very simple? Uh, it depends. It's not very simple if you want to feed hundreds or thousands of fishes. It's not simple at all if you want to feed them very accurately. To give a background, our customers from fish farms had a problem. They were having a fish farm where, for example, there will be a lot of pools, and each pools will have, for example, 10,000 fishes. They have about 10,000 fishes by average, and they have like numerous, a massive amount of pools in one farm. So what they do is like they try to feed, and they have also automated these feeding lines. But it can provide food, but how efficiently is a question. For example, they had a lot of challenges. For example, in a pool, if you take one pool in that 10,000 fishes, say for example, if 5,500 fishes are, or like say 100 fishes are bigger than the average fishes, then what happens is like the bigger fishes would start attacking the smaller fishes, and again, so there will be a lot of dead fishes, and that will increase the diseases in the pools. So similarly, if you feed more food than needed, that would create a more biomass, and that will also cause disease for the fishes. And if you provide less food, then the growth would be lesser, and they won't be able to get a bigger yield to sell it in market. So this is a problem they have. Problem factor is that, and then their help is that they asked us like, can you help to do something intelligent with using AI or some other various technologies. So we said yes, let's have a look at it. So our data scientists and our innovation team went to have a look at the farm, and this is the farm. I just wanted to give, this is one of the most clearer video from top I could get. This, what you see, the black areas, all the black areas, what you see here are all fishes. You can see how densely they are populated, and we need to find out what are the fishes bigger than the average sizes. That is not so easy. That's crazy tough, and we were like quite taken aback. So we were thinking like various ways. So we came back to office, and then we thought about like various ways. And our computer experts, data scientists, these are the elements we need to predict certain things accurately. So one of the technology we need to use is computer vision. Computer vision is basically you put a camera, and then with that camera we train the model. With that camera footages, we train the computer to predict what is going on, or analyze what is going on. So for example, if we are seeing something, we can easily guess. We have sixth sense, but AI won't be able to tell certain things. So we need to tell them that this is fish, this is bigger fish, and this is skin diseases, and all these things we need to train the computers. So the data scientist said, okay, we have to use computer vision on. So we said, okay, let's take some underwater cameras, let's go there and then capture some footages. So we went there, and we insert the camera inside the pool, and this is what happened. These fishes are so ferocious, they started attacking the cameras, and you can see the clarity inside, like, because of the biomasses and stuff, it's not so clear. And we are not able to get anything, we are not able to get the clarity, we are not able to get the right lighting conditions, and on top of it, the fishes are attacking the cameras. So these are some of the areas we were like, oh, what should we do with this? So the data scientists came back to us, and they were telling about these problems, and they showed like similar footages, a lot of footages. We tried with various way, but still we were not successful. Then we thought, I have a photography background, and similarly, my team members have a few other creative talents. So we thought like, why don't we try something? So we said, we'll look into that aspect one by one. Let's structure the problems. And then we said, like, okay, first of all, we need to identify how we can get a decent video footages. So we actually worked on a lot of areas in photography and videography. Actually, even I worked on photography for like many years, and I studied in my bachelor's as well, in Karunya. But combining all these years, I learned a lot in this project because it was pushing the limits. And we did a lot, like, we engaged also an agency to understand, like, how we can control certain things, because it gets more and more complex. For example, some of the basic elements we looked at is like, for example, we don't care about ISO, the noises are fine. But we want to have like as much less lighting conditions, because if we put bright light, the fishes would get scared and they would attack again. So we had to do a lot of aspect. We have to bump up the ISO. We have to increase exposure, but like, we need to have the proper shutter to get achieve like certain FPS. At the same time, with the clarity, like, the sharpness we need. There are a lot of aspects. I can go on and on and on. We looked at in this aspect one side, and the other side we have to also look at like rigging. So we have to get find a way how we can get these cameras to go underneath the water. So there are like specialized rigs we made, because the water is flowing. There is inflow water, there is outflow water constantly from sea. So that the tank is cleaning the biomass always. So there is, since the water flow is there, it's a bit difficult to keep the camera stable. So we had to make a specialized rig to achieve this as well. So in the photography and videography layer, we did a lot. We worked on with a lot of photographers to understand how to do this best. And underwater lighting was another challenge. How we can do this, how we can filter out, how we can reduce the reflections. We worked on this. We worked on some simulations to get the right lighting conditions. We couldn't do everything from top. We had to do certain things from bottom. Like, there are a lot of things we worked on it as well. So these lighting layers is something very, very interesting as well. I am a person who loves natural lighting, so never played around with lightings. When we worked on these projects, I learned a lot about lightings. And then we also worked on behavioral science, that how fishes are behaving. So we studied a lot of materials and stuff. On top of it, we learned a lot from the farmers. Actually, they are the one who knows how the fishes are behaving, at what time they had to food. They know a lot of information. So we learned from them a lot, and then ultimately we are trying to help them. So they are also happy to share a lot of information with us. With this behavioral science, we created like sort of things which would distract the fishes. At the same time, we can go and take the camera footages and stuff. So this is what we did. We worked very hard on these three topics, and then this was the final outcome after we do all these things. The fishes are quiet, calm, the lighting is not irritating to them, the camera is not disturbing to them. We did a lot of things for this to achieve. When this footages was out, our data scientists were so happy that they could do a lot of things, and they were thankful to us. And then we were curious. So what are you guys going to do with this? And then they said, okay, so we are going to do annotation. So we asked, what is it? So basically, annotation is like, they did some parallel research. how we can size a fish. Basically, if you see a fish, you won't be able to tell the weight of the fish, right? So what they are trying to do is like with the fish shapes and sizes, the swimming ways and stuff, they can actually identify weight and what disease it has and stuff. So they did a lot of research on that, and then they were saying that okay, so we take this hour-long footage, we are going to annotate all the fishes. So basically, they are going to draw each and every fish, like not every fish, but at least like few fishes in certain particular directions or angles, and then they have to draw this for all these 1 hour footages, and they are going to give this to the computer model to get trained. So this is the idea. And when we heard it, I was like taken aback. I was like, come on guys, like there are in movie industry there are people doing it differently. I mean, 15 years back, I was doing this in After Effects where I have to track all these things when I was doing visual effects. So I was telling that why are we doing this now? Why can't we do it automated? They were saying that there's no other tool, and the data science team or the data science field itself never cared about it because this is Hollywood was something different, right? So what we did there then was we quickly imported this footage. We opened After Effects. We tried to match and get something. We got a decent output, but then it was not sufficient for the data science because it was not that accurate. Then what we tried to do was we again started thinking out of the box. So we said, okay, let's take a 3D model of this fish. We create a 3D model. It just took like half an hour to 1 hour. So we create a 3D model, and then we placed like some, based on their research, we placed certain elements which could help to create that annotation in a 3D model. And then we simulated the fishes, how they are behaving in a game engine, and also using 3ds Max. So when we did that, we worked on a lot of animations, 3D animations and stuff. And this is what we did in 3D animations. We calculated how the fishes are swimming and stuff. So with that, they actually were able to recognize automatically what are fishes, how they are swimming, and everything. And with this model, with this animation, actually they trained that model without doing manual annotation and stuff. When they did that, like they saved a lots and lots of time, because you can imagine that when you go frame by frame, multiple fishes, like drawing, how long it would take. So with that, we managed to efficiently do this, and the final outcome was this. So now this is the outcome, like where we are actually managed to predict all the fishes. It's, I mean, it won't be like accurate the edges, because as long as the computer detects it's a fish, it would move on to the next fish because it has to detect multiple fishes. And this is real time. When we show a footage, like it would real time render all these things, and it would calculate this fish has this fish is this ID, it has like this disease, it has some problems, it has, this is the weight of the fish, this is the size of the fish, all these things it can recognize. And this will go into a dashboard where the farmers can see everything and say, hey, this pool has like 7 fishes which are big, we might have to remove it, identify it, and we can, like and also we can also feed the fishes based on, like how their behaviors are. So there are a lot of things we did, but the achievement what we did managed to do here is quite impossible without the creative elements what we used. I mean, we could have still done it, but like not efficiently, I would say. So you can imagine like how important is creative technologies are, like photography, underwater lightings, like 3D animations, behavioral science. All these things are like so crucial for getting this efficiently. So the next project we want to bring in is 3D real-time digital twin. This is a project we did for a transport authority. Autonomous vehicle is getting crazy, and every country is looking into that aspects and stuff. But these topics, right, like this infrastructure or industrial topics or anything, it takes a lot of time to get implemented. And the main reason when you see is this: most of the infrastructural developments or industrial developments are actually made by engineers and for engineers. And when the engineers find out that this is what they can do, and they are taking to the decision makers or customers or clients, it's impossible to get an answer quickly. So they take a lot of time, because uh, the clients are not engineers, the city mayors, ministers are not engineers. Like, no, they have to understand something in a simple term. When you show something like this, it is very. confusing to them that what is this, like, an engineer can understand a lot of things from this, but like a normal man cannot do it. So that was one of the things what we saw, that we could help in the autonomous vehicle side, because there are a lot of technologies. Like Siemens is very strong in mobility, but what we are doing here is basically we were not doing anything with, for autonomous vehicle, but like, sorry, we are not doing anything with autonomous vehicle, but what we are doing is we are developing an infrastructure which would help autonomous vehicle to understand the place. For example, if there is three traffic junction, the autonomous vehicle is in the third traffic junction. It needs to come to the first one. So when it comes to the first one, when it stands in the third one, it will not have any idea about what is going on in the first one. Because of that, it only sees through the camera, lidars, that's all. But when it goes close to the first junction, it will know, okay, there are crowd here. I need to reduce speed and stuff. But sometimes it's not efficient. In the dark, it raises more questions, like, about the safety and stuff. This is where like a lot of things are happening around. So what we are trying to do is we have infrastructure throughout the cities, like lidars and radars, computer visions, cameras, which would tell all the autonomous vehicle in this whole zone that what is happening, what are the important elements are happening. So every autonomous vehicle in that zone will know what is happening around in this whole intersection, or like the whole area. So if the area compromises of like maybe, I don't know, like 12, 13 like traffic interjunctions, so they will know what and all is happening around this whole area, so they can take better decisions. So it was very difficult for the engineers to convey this topic, how our infrastructure is helping the people, the autonomous vehicles. So what we did was we tried to take a different approach, just like storytelling, what we learned, right? So we did storyboarding of how we can tell the story to the user, like, not just showing the engineering and the capability or the feasibility, but like telling them what is the problem, what is the solution. This is what we did in a storyboarding. After storyboarding, we did a few video footages. It was not sufficient because it was not efficiently communicating, so we made 3D models and we made 3D animations, and we did a lot of VFX. So basically it's a marketing animations. We use this to show the people what is happening, and this is not something new, like, other companies are doing that as well, but mostly focusing on consumer groups, like, for example, a consumer company, when it wants to sell an phone, they make a lot of animations to explain their technology and stuff. This is not something very prevalent in industrial or infrastructure side. So we started doing that, and with that we basically told, like, this is one of the story. Basically, when the car comes in, it is blinded, and then when the human is going, it needs to reduce the speed. With just autonomous vehicle, it won't be able to do that. Like, for example, when the car is here, it is not able to see this human. So, but since the infrastructure is already telling that there is a human passing, it automatically slows down, and then when the human passes, it continues. So stories like this, right? So we developed a lot of these kind of animations, and we presented this, people understood very easily, and then there were a lot of decisions made faster. So it was very, very successful for us, and then we moved on, and then we thought, like, hey, we are moving on too quickly. I mean, this is done something somewhere, like, we implemented this, but why don't we take it one step ahead, like, one more step. So we took the whole idea of storyboarding, modeling animations, in a movie field, but we are an engineering company. Let's apply whatever we learned into something. So what we decided to do was this: we started taking piece by piece. We converted storyboard into concept. Like, we created a concept that what we can do with this. We created like a modeling into libraries. Not only in order to tell a story, we need only 5 elements. In order to create a product, we need 50 elements. So we created a libraries, and with 3D animation and VFX, we started looking at rendering and game engines, using game engines. With all these next steps, what we tried to do was, with the data we are collecting at the background, like, from our BUs, like, lidar, radar, it tells basically the autonomous vehicle what is happening around, how there is a 5-year-old kid running erratically with a ball, so maybe you should reduce the speed, things like that, right? So these informations are basically communicated to the autonomous vehicle in a very digital way. You won't see it, right? So what we tried to do was, like, let's create a digital twin to showcase this to the people. So with these, what we did was this was the outcome. Um, this is just one of the video just made to explain you guys. So this is the actual test field we have, and we actually, when the cars are moving, we actually started putting it in the grid, and we can actually visualize which car is in what grid and stuff. So this is hugely useful because like people don't need to rely on data. Generally, the dashboard will have like, hey, this road has 2 buses and 3 cars and stuff. But this is not quite efficiently conveying something to them that how crowded it is. When you visually put it out that like this is how it is crowded, people are like very amazed, and then they can make decisions faster. So we did that, and then what we also did was we put this in real-time digital twin. So for example, what we did here is like we did a traffic intersection. When the cars are going in the digital twin, also there will be a car spawned and growing. When two human walks nearby the car, it will spawn the humans in the 3D digital twin, and they will go. So whatever happening in that intersection, we are creating in real time 3D. That's like you're looking at something, and then in 3D, whatever you're looking at is created in photorealistic way. That was something, it was very hard to achieve. We managed to achieve this after a lot of hard work. We also worked with a lot of good partners to achieve this. When we did that, the potential was amazing. Like, for example, say autonomous vehicle, say we are in a time, we go to a time where everything in the road is autonomous vehicle. So that time, say bus operators have to tell the government agencies that like this is how my bus would perform, and then they will say that at the turning, I will turn at this angle. I will only go at 20 km/h. But in real world, it might not go. Like sometimes it there could be some bugs or something which the bus might go in a different speed. So these are something we can capture and tell the government, and even autonomous vehicle can capture and tell the government. But the government agency to give a proof to the companies that hey, this is what happened, is by video footages, and that is very difficult because every city footages are very sensitive. The government will not share it with anyone. So a country's footage, CCTV footages. So what we try to do there is that basically with the digital twin, what they can do is they can actually share only the real time the renderings, and they can filter out, take out the cars, take out the humans, take out the buses of this operators, only take the bus operator, this one, and then they can filter out in real time, and they can capture this and then send it as a proof for penalizing the company. So these are one of the potential, but there are a lot of things we could do with this technology. So this was good, and then we are already like applying it in not only in mobility areas, like we are applying it in many other areas. So this is one example I wanted to show you guys with as well. So this is the autonomous vehicle, what you see here. This is our tiny autonomous vehicle. We are testing this autonomous vehicle, and you can see at the background how this autonomous vehicle is rendered based on what is happening outside. If you see outside, autonomous vehicle is going left, and so even in the digital twin, it is actually going in the left. It's all rendered in real time. So this is what we are trying to do in the 3D real time digital twin. Again, another project where I learned a lot, and where we used a lot of creative technologies as well. The next one is, and the next one and the last one is building twin. Building is a place where we spend most of our time, especially during this lockdown. Like we are spending all our time in the buildings and stuff. Even when we go to out, like building is something like an integral part of our life. And when we face a problem, for example, when we face some issues in a building, like if you're sitting in office in a meeting room and your air condition is higher or warmer, you are telling the facility management. You call the facility management and tell them that it's warm. They take 3 hours, 4 hours to fix it. But we are getting frustrated with that. We also like saw that from our team, and in our office, like it happened a few times. So we thought, why is it slow? Why don't we help something? So we took this as a pet project, and we started working, and now we productized this, and we gave it to a lot of customers. So let me go from the problem aspect. So what happens in a building when something is going wrong? So for example, let's create a scenario where the air quality is bad, or the temperature is warmer in the meeting room. So you call facility management and tell them. So this is the way the information is coming in. So they can either you call them and they note it down in a paper, or in a smart building where the sensors are there, like the sensors would detect that the temperature is higher than normal, so the sensors are detecting. These are the source of income of informations. The next way, like in the paper side, they manually enter into a tool which will schedule tasks to the maintenance engineer. In sensor, from the digital side, the sensors are feeding into BMS system, that's building management system, and the building management system will trigger task to the automatically task to maintenance engineer. Both way, the maintenance engineer, from his perspective, he gets a SMS. When he gets a SMS, it's basically two types of SMS. When it comes from sensor, it says that, hey, this sensor ID 051 or something like that is telling that the temperature is warm here. Go and have a look at it. This is one type of SMS. The other type of SMS is something like, hey, the people at this meeting room is complaining that it's warmer. So it's a very like area specific information. Another is digital specific information. With that, what he has to do, that he has to goes to for example, if it comes to if it comes from sensor, he needs to open like an Excel sheet, and then he has to find the sensor ID and then where it is, and then he has to open a floor map, find out where it is, and he gets the detail. From the manual side, he takes it from the approach of, he takes a floor plan. Oh, this is the area, these are the sensors available here, and what are the sensors he takes from Excel. Both way, he is doing a lot of things manual. It takes about half an hour to 1 hour to identify this information, and then they go to the place, and then he is the Superman. He's going to fix the issue. So once he reaches the place, he finds more difficulties, and these are this. He finds navigational issues, like if a building is huge, like a few floors, it's not a problem. If a building is huge, it's very difficult. So one of our customers we recently worked is having 50,000 sensors in that building. Like, you can imagine, it's I think like 40 plus story, three buildings, so it's like around like 50,000 sensors are there. You can imagine how this engineer will find out these sensors and stuff. Like, it's crazy. The second thing is, even if he find out that location, he goes there, and he needs to find out what is the actual problem. Like, he needs to figure out, like, he needs to debug a lot of things and stuff. And data transparency, whether this was happening before or anything, is not there. It's also manual. And also guidance is like, if if he is a new engineer or she is a new engineer, she might not know that how this is happening, or like what would be the call to action to fix this. So these are things we observed, and we thought how we could help the guys. And we decided, since it was a pet project, what we thought was, let's take it in a very gamified way. Let's make it fun for the people to use it, because this is something we wanted to test it. So we created our whole office as a 3D model, fully 3D model, like photorealistic 3D model. And then we put in all the sensor details, everything, and we brought in, we learned from other projects how to bring in real-time data into 3D game engines. So we took that and we put it in this building twin, and then we started seeing real-time data, and then we created a lot of features around it. That was this. I will show this video. I can navigate you guys through the video. So this is our office in Singapore. So you can actually walk in, just like first person view. Anyone can walk into the building, and you enter the reception. You see the photorealistic. People can easily connect. Yeah, I have been there and stuff. You can go to the reception. You can find the real time information of how this building is performing. And also they can see if there are any KPIs defined for the maintainer. They can also see that. With that, they can quickly see the performance of the building. Previously, I was mentioning about this alert systems, right? So this SMS alert, what they have to do, and with this application can run in mobile now, so it's mobile friendly. So when they get a notification that, hey, this is happening, what they can do is, all they have to do. So in this case, like, there will be a poor air quality detected. So you just need to select it. It automatically does a path finding to show you how you can go to that place. So this is office space. this is the meeting room where the air quality is poor, and this one is the sensor which tells that there is a problem. So it's highlighted in yellow color. So once you open the sensors, it will tell what is the actual issue. Yeah, air quality is poor, but there are various factors for that. So in this case, it says the CO2 is higher in this area. So what he can do is, okay, this is good, like, the CO2, then he can narrow down only three causes for CO2 to be higher. So further, he has to still investigate whether it happened in the previous or not. So what here we did was we tried to learn as we collect the data, and then with maintenance logs and everything, knowledge graph, we can actually advise the engineer that this could be the issue. In this case, it's going to, yeah, it's telling that this outlet valve is was not maintained for past 3 months, so the carbon dioxide is not able to go outside, and this is the reason behind the CO2 to be higher. So it is a guidance. It is not the truth, but it is the guidance that it could be a fact. Maybe you should have a look at it. So it gives a priority of things for him to have a look at it. So this way he can easily fix it. So with that, we actually made him more productive. Like, our facility engineers are like actually more productive because they are able to quickly do. On top of it, BMS, how they are observing the buildings are basically they are sitting in a basement with control centers, like, and the control centers have like all the numbers. They can't predict anything. So we also made a visualization like with this tool. Now, like in the dormant mode, like, it always, the camera will be always walking through the different spaces of the building, and while you walk through the spaces, you can see these kind of hotspots. Like, if you see, there are some hotspots which are red in color. So if something is yellow or white, they are okay, not bad, some warnings and stuff. If there is something red, then it means that something is really bad. So, for example, in here it is red, so people can walk in there and they ask what is the problem. Here it says the TUC and the temperature is higher, which means the temperature is higher, so they have to do some actions. In this case, TVOC means someone is wearing a strong deodorant, right? Like, or something leather products or something is there. It's artificial smells. So these kind of things they can easily like identify through the whole building, and they can do a lot of things. Similarly, like there are tons of features. They can go to even like chiller to do maintenance job, like, how the chillers are performing. They can see like more in-depth details of the chiller informations. All these things they can intuitively do in a game engine. This is something like we could only thought of it like from the creative side, and then we poured in, and the technology side grabbed it, and then we started doing it. I presented this at World City Summit, and here what we did was, you can see I'm not using a keyboard. Actually, we put this in Xbox, and we actually control the whole building from Xbox controller. So that was so efficient. People loved this idea that, like, how we have managed to do all these things. It is just like a thinking a bit differently, but the problem always stays. When you think differently, you can find various answers, and that is what we did here. And also our customers also comes with like a lot of ideas as well right now, or new problems as well. So in this way, in this here what they mentioned was that hey, this is good, like, but some of our engineers are having low cost tablets which are not able to do high rendering. So what we can do here, like, so what we did is, this is a low poly 3D models. It's not first person, but like you can do a very efficient analysis of the building. So for example, you can go to the building and you can see like where the fingers are. It's made for tablets. These are also comes under the UX. So you can go to the different buildings, you can select different buildings, and based on the buildings you can select different floors. And if you select the floors, you can go into that particular floor and you can see all the sensors, and you can also see how the floor plans are, and you can select even the sensors. For example, here I'm selecting a sensor. I can select a zone and see how this zone is performing. And also what I can do here is I can see scheduled maintenance, issues, events. So for example, if this floor is having some event, and the facility manager, first he needs to see is there any scheduled maintenance happening here, or some, these things are all in manual forms and stuff. With this iPad, like he don't need to do anything. He can just click, 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 and then he can identify all this information. So we're creating a huge data transparency for them to make a better decision faster, using various creative ways. So these are some of the examples I wanted to share with you guys, that like how we are using creative technologies to advance IoT solutions. And there are so many projects I could share. Considering the time, I will stop here. What I wanted to share is that, like in Siemens alone, we have achieved this, and I have some of my friends who are working in sports agencies. One of my friends is working in a sports agency where they are taking care of surfing. Surfing 10 years back or 15 years back, it was different. Like, no, they were shooting it from helicopters, drones, and stuff. Right now, they are shooting it there, but on real time they are also showing like how much spin they are taking, what angle they are taking, if they are fall, what is the reason behind the fall. All these things they are managed to produce real time, and they are showing it to the viewers to create an immersive experience. Similarly, you can see that in cricket as well. Now you can see much more intelligent technologies are coming in to explain the viewer what is the best way to um, understand this easily. If you look at it, it's a lot of cool technology, but behind that is all communication. Communication is a major point. As a visual communication students, you should not think yourself as just arts and science people. I would only work on photography or only work on like this is my area of expertise and stuff. You should think beyond that, like your expertise is communicating some information because certain group of people are not able to understand it, and you are the key people who can bridge that gap between the technology and the people. So with that, like you have to think outside the box. You need to think outside the box how you can use your talent to help the world to be a better place. And this is very, very important. If you could be a talented photographer, but if you are only doing photography in case of like travel or wedding or like a particular type of photography, and you're building your business only on that area, you're restricting yourself. You should build something for yourself, but you should keep exploring, keep learning, and this would take you to an area where you never thought you would be, and you can come up with some extraordinary outcome. Like this is the points I want to leave with you guys, and think outside the box and build your career. Thank you so much for listening. And if you guys have any question, please leave in the comment box. I will try to answer as much as possible. And you please feel free to follow me in LinkedIn. And I have always like been active, and I post a lot of things what our teams are working on as well. So please, you can follow me in LinkedIn as well. Okay, the questions are coming in. What we have to study for creating such a IoT apps? Uh, Again, it's not about what you are studying, right? I mean, as I mentioned in the end, you have to constantly learn something. Like for example, my career, like tweaked into different. I was a designer, then a developer. Um, Now I'm doing managerial role where I have lesser design and lesser development work happening right now, but I have to keep the spirit. So I am because if I don't do, I would forget the technologies and stuff. So I'm doing a lot of pet projects at home, and I have to keep myself active. In terms of study, I think I would recommend you guys to use a lot of online portals, or like be active in your community, your friends groups, where they are working on different technology. Learn the topics, and then you can find it everything online. Like you can learn everything online, but don't just learn and study and keep it to the books. Also apply it somewhere where you can see the outcome, where you can see the problems it creates, where you can see the problem it solves. Like so look in that way. I won't recommend any particular studies or anything. The there is a huge opportunity. It's an ocean full of opportunities, I would say. There is no particular course which would enable you to be successful in that. Again, if you are doing photography, you can learn about a lot of things about photography. Photography doesn't stop with just clicking and editing images in Adobe products or like some other editing softwares. It is beyond that. Like, you can work on a lot of things like how camera works. Make your own cameras. You will learn a lot about you as a photographer know a lot of problems you're facing. So when you know how to create a camera, there are all the spare parts are available. Create your cameras. It might not be competing with a Canon or like big brands and stuff, but at least you know what it is, right? So this is important. Oh wow, there's a lot of questions. So, what is your advice to think outside the box and be visual communicator? I think I said that in the in the presentation. If you're good at something, for example, photography, and if you think that I'm taking photography again and again because I can connect easily with that. Um, if you want to be a better visual communicator, go from the problem aspect. For example, you are targeting a group of people who should see this, and if you feel that way, if you feel that these groups should follow you, or like if these message should be conveyed to this group of people, look at what would they want, like come from that problem, like this is what they want. In order to achieve that, I need to do this. So when you come from that route, you will see a lot of missing pieces you need to go to where you want, and that end goal is what the communication I meant. So find that missing pieces. There is no typical way or phase or method we can choose. Like, it's always, everything starts with a problem. You look at the problem, identify the problem, and then you go towards solving that problem. When you go in that path, you will find a lot of areas where you can innovate. And this is the general template I always follow, and that includes to my team as well. It's our basic course to develop knowledge. Again, I said the exact thing. There is a major disadvantage of human being due to laziness is increases by human beings. Even though this is one of the disadvantages, also, it is possible to future in India. But it is possible to future in India. Mm. So basically, if I am understanding your question, you're saying that humans are getting lazy, um, and there are technologies advancing. But can this happen in India? It will. I mean, India is not lacking behind in technology. They are doing a lot of things. I mean, we have a big team in Bangalore, and we are also seeing what they are doing, and we are collaborating with them as well. They are doing in a lot of areas, a lot of things. We have to look from different aspects, how things are in terms of technology. There are a lot of things happening in India. From addressing the other point, humans are getting lazy because of technology. Um, it is a very different way of seeing. Yes, they are getting lazy, but I would not consider myself thinking that way. By doing the home automation, I'm also listening. Like, I'm also getting lazy. I can tell the home assistant to do anything I want in my home. Like, I can sit in my couch and I can do everything. But what is important is that, like, how I can automate certain things, certain elements and stuff. Most of the time, these kind of things are helps to make a better decisions sometimes. So in home in instant, like, when I leave the home, my assistant will automatically alert me in my phone saying that, hey, sorry, I see you and your wife is not at home, like, but the aircon is on, like, can I switch it off? I can switch it off immediately. I don't need to come back to home to do this. I can do it. It helps me to make a better decisions faster. And this is what I would tell in industrial and IoT space as well. We are enabling humans. I mean, ultimately the decisions are made by humans. We are enabling the humans to make a better decisions. And with that, if the computer is aiding, be it, like, I feel like that is the right way to look at it. um, Again, um, courses. uh, Guys, again, like I would not recommend any particular courses in this case. Um, I would say like we are not in we are 2020 now. Everything is online. Like whatever if you feel you should study, you should study. Like you can learn like everything, and everything is out there in internet. Like I'm seeing like I was thinking that again I'm bringing back one of the knowledge is that I was buying a lot of IoT products and I made a lot of automations. But still, I was fascinated that every time I switch on and switch off a light, the data is going to some third-party company and it comes back to my light. And I thought like this is crazy. Like why should I do that? Like can't I just buy IoT device and allow any data not to go outside? Like I want to control everything here. I don't want any third-party services. Can I program it myself? And there are ways to do it. And took me 3 months to study this in my free time. And now my whole house is like completely automated. Even if the internet is down, my home can completely run as much as possible. It can even connect with me, but not with any third party and stuff. But I learned this online, like in a matter of months. Whether implementing IoT, is it necessary to know about coding or sensors? um, Good question actually. So it happens. I mean, we face this, right? In our team as well. We face that there are a lot of people who don't have sensory knowledge, like how a particular sensor work, what type of data it provides, how we are creating this data pipelines and stuff. I don't know. I never worked on that, but I'm learning that now. It is helping me to make um, my solutions faster, but at the early stage I didn't. So my answer would be like it is necessary for you to know at least the basics of coding and sensors. For example, our developers are developing a lot of HTML based applications, like a lightweight application. um, from their perspective, they are coming from gaming background. Their perspective, the look and feel is so important. Like they would create utmost importance to this look and feel. But then what we faced was these designs are hard to implement, like very hard to implement. So the developers were um, facing a lot of issues. So what we decided to do in our team was like we have fifth day, that's we work only 4 days, and the fifth day, that's Friday, we all go to office and then we actually do a knowledge day. So that the whole every Friday for us is a knowledge day. We do a lot of pet projects which will help the business and stuff. So from there, what we use that space for was a designer can learn from developer and developer can learn from a designer. For example, in order to do a design, what are the problems it would create from the front end side, like development side? These are something we learn. Our designers are learning. So in that case, like from as a Viscom students, I think you should learn at least the basics of coding. And coding is getting very mandatory in a lot of countries right now. Like even primary schools are getting like basics of codings these days. So my nephew, I'm also pushing my nephew into program coding and programming, so because I feel it's crucial. Is IoT is used in animations? Of course, yes. It is both way. Like we are using animation in IoT development, but we are using also like IoT in animation. Like for example, rendering farms and stuff. There are a lot of ways. Like that was my final year project back in Karunya. Like I created a rendering farm and we rendered uh, crazy high poly animations at that time. Uh, but that time the technology was low. But I learned a lot now that I could do more and more efficiently those animations. Like for example, power supply. Like how I could control scheduling systems to assign jobs for the different rendering missions. So these kind of things I could have efficiently did it now. Back then, yeah, I didn't have idea, but and also the technology wasn't available. So yeah, that is a way. Um, how would IoT be of help amidst pandemic crisis? Um, Actually, very relevant. How is IoT useful in a crisis like right now? Uh, Actually, I mean, we are locked out at home. A lot of things are happening. For example, if you imagine, like, we are working on energy sectors as well. If you imagine, there are a lot of maintenance has to be done uh, in the energy field, and people are not allowed to go to work. So, for example, in Singapore, certain offices are mandatory to work from home, and there are a lot of restrictions in moving around as well, except the key personals. So, for example, in this case, for a company to bring an employee to do certain things is very, very difficult, and especially in a crucial industry like energy, like which provides power to houses and everywhere. um, they have to do a lot of maintenance jobs and stuff. And if this is 10 years back or 15 years back, people have to be there at work or physical space to do a lot of maintenance. They don't need to do it anymore. And we are doing everything remotely these days. And IoT is the only thing which has made it possible for you guys to do all these things. So I certainly believe that we wouldn't be this comfortable during this crisis unless until the technology is helping us. Like, even I can connect with you guys using like communication technologies, right? So similarly, the technology has to grow, and this without this, this crisis would have been much worse, at least. Okay, I think that's a wrap up. It's 1 hour right now. So thank you so much for being patiently listening to my talks, and thanks for the good questions. And again, if you guys have any questions or anything, please connect me LinkedIn, and you can shoot your questions. I will try to answer as much as possible. Thank you so much.